Continuing our look at complex numbers and their graphs, our objective in this video lecture, we want to add and subtract complex numbers graphically. We're also going to be using our calculators to check our answers. Okay, what do we know? What do we come in understanding that's going to be helpful? We know what a complex number is. It is a combination of a real number and an imaginary number, made up of a real part, an imaginary part, and the imaginary unit, which is the square root of -1. So it's an a plus bi, where the a is a real number and is the real part. The b is a real number and is the imaginary part, because it's being multiplied by the imaginary unit, the square root of -1, which is represented in mathematics with the letter I, and usually in technical fields, particularly electronics, with the letter J. We learned in our last video lecture that complex numbers can be represented by a vector from the origin to the given point on the complex plane. Remember, the complex plane is made up of a real axis and an imaginary axis. The third thing we know from some lectures on vectors a long ago, when two vectors are tail to tail, they can be added graphically using the parallelogram method. So we'll pull that into today's lesson, excuse me. And number 4, vector subtraction is done by adding the opposite. Very similar to perhaps how you learned integer subtraction. So we're going to add the opposite when dealing with vectors. All right, let's take a look. Put those things together. Get myself straightened out. We want to add 1 plus 2j and 3 plus j graphically. And we want to check our results with our calculator. Okay, I'm going to be a little more precise with, obviously not with my horizontal line. Okay, so let's recall this is the x-axis has become our real axis, so we're going to label it such. The y-axis has become our imaginary axis, so we're going to label it such. And I'm going to be more careful with my tick marks, because we want to add these graphically, and in doing that, it's going to make a difference in getting the answer if I am a bit more precise. Hopefully that covers it. Okay, 1 is the real part, so I'll be over here on the real axis. 2 is the imaginary part. So this is the complex number 1 plus 2j, 1 plus 2j, represented as a vector. Okay, 3 plus j. 3 is the real part. There's a coefficient 1 here, which doesn't need to be written, it's understood. So 3, 1. Okay, I hope I got that. I may want to go up a little bit higher than that, to maybe here. And this is my complex number 3 plus j, represented by a vector on the complex plane, real, imaginary. Now adding, we can draw what we want to do here is we want to draw a parallelogram. So now I'm going to be, I know the answer, so I'm going to make this happen with in knowing the answer. Okay, we'll go here, and we go here. So I took this, moved it to here. Okay, and yeah, I think that's right. Yep, and I took this one I drew that one over here, and I made a parallelogram. And now I go from the origin to the opposite side of the parallelogram, and that is the sum of those two vectors, and this is located here at 4 plus 3j. So that is the sum, the sum of the two complex numbers 1 plus 2j and 3 plus j is 4 plus 3j. Again, I'm not, I got a little bit off, but if, to do it, to do it with some precision, this probably should be a little bit shorter. That might be a bit better. But anyways, you get the idea. Let's do this with our calculator. Okay, so that's graphically doing it. So let's see, what is 1 plus 2j plus 3 plus j? Now, for those who recall how to add vectors, you add the real part and you add the imaginary parts, and you can see this is 4, 1 plus 3, and 3j, 2j plus 1j, and you get 4 plus 3j. That's how you do it algebraically without a calculator. Let's pull out our calculator and see how it's done. What's important to note here in your calculator is you need to be, as we've seen in other applications, parametric equations, you need to be in the right mode. You'll notice on my calculator up here, it says real. I am currently in the real number mode. Well, this is the complex number mode, so I need to go to mode and come down, looks like it's, let's see, row 1, 2, 3, 4, 5, 6, 7, row 8. There's the real. If I go over 1 to the a plus bi where it's blinking, that is the complex number mode. I'm going to choose that mode. And notice it changed up here, and it changed up at the very top, and also says number type real / we're in the complex mode here. So now I can quit out of that. And I like to put these numbers in parentheses because this really matters in subtraction, and so I keep myself consistent by always doing it. So I'll use parenthesis 1 plus 2. Now again, mathematicians use the I. So you got to find the I on your calculator. In my case, it is the blue key above the decimal point at the bottom. So second I. Again, it's the blue key, the very bottom in the middle above the decimal point. So that's my first complex number. I will add that to my second complex number, 3 plus simply a j or an I, the complex, the 1. So I'll go back down and pick up that I. And so again, I like to use parentheses. If I always use parentheses, I feel better about how the answer is going to be because it does make a difference with subtraction. I'll press enter, and you can see because I am in the complex number mode, I get a complex number answer, 4 plus 3i, which we've now gotten, 4 plus 3j in our case, which we've now gotten in 3 different ways. Okay, let's do one more example. Let me slide some things out of the way here. Let's do an example where we do a bit of subtraction, remembering that subtraction in vector lingo means we're adding the opposite. Given the complex number, example 2, given the complex number 1 minus 3j, subtract its conjugate graphically. Check with your calculator. Okay, so let's see here. 1 minus 3j. The conjugate is the same two terms with the opposite sign between them. So the same two terms, 1 and 3j, with the opposite sign between them. That's the conjugate. So I want to take 1 minus 3j, and again, I'll put this in parentheses, and I want to subtract the conjugate, 1 plus 3j. Okay? So, given this complex number, subtract its conjugate. Given the number, subtract its conjugate. Okay, how do we subtract in vector world, in vectors? Well, we do 1 minus 3j, and we add the opposite. So here is the adding the opposite. The opposite of 1 plus 3j, the opposite of 1 is negative 1, minus 3j. That's the opposite. Add the opposite. So now I have these two vectors, and I can add these graphically. Okay, let's see here. And I'm going to check it with my calculator. Now again, I kind of know how this one's going to work out. So I'm going to, well, let's move this over a little bit more. So I'm gonna draw my axes like this. And again, this is the real axis because we're graphing in the complex plane. So we're going to label this real. And this is the imaginary axis. The y-axis becomes the imaginary axis. And let's see, I need a 1 and a negative 1. So I'll do those as centimeter marks. On the real axis, this is 1 and negative 1. And I need to go down a fair piece further than I had it. Let's see if I can get it down there enough on the paper. I think I can squeeze it in. Gonna be close. So there's 1, 2, 3, 4, 5. Whoop, close enough. Okay, so I know I need a 3. I need a negative 3 down here. Okay, let's make sure you can see all my work. Okay, so let's see here. 1 minus 3j. 1 minus 3 is here is the 1 minus 3j. Okay, so there is this is my complex point represented as a vector 1 minus 3j. Okay, again, we can represent a complex number as a point or a vector. I'm going to add to that negative 1 minus 3j. Well, here's the negative 1, the real part, minus 3, the imaginary part. And that's going to be about here. And so this is the vector negative 1 minus 3j. Okay, adding two vectors we can do with a parallelogram. And again, I already know how this is going to turn out. And if I'm careful, I can draw the parallelogram. There's my parallelogram. These are the first two sides. I took this side and copied it here, and this side copied it here. Or you could put this one on top of that one, go head to tail. And I come down, and as it turns out, the addition of those is this vector right there. And my paper got turned, sorry about that. And the addition of those is the vector 0 minus 6j, or it's just negative 6j. You don't need to have the 0, but it's 0 on the real axis, and it's negative 6 on the imaginary axis. So that's how you would do this one. Let's check it with our calculator. And as a reminder, I would put these, remember, I'm going to do this right here. I would put these in parentheses so that my subtraction takes place correctly. Subtract its conjugate. So 1 minus 3j minus its conjugate. Its conjugate is 1 plus 3j. Okay, so this is what I'm looking to do algebraically. Again, you can probably see there's your 1 minus 1. When you combine your real parts, there's your 0. And here's your negative 3j minus the 3j, which is your negative 6j down here for those who have done adding and subtracting of complex numbers. Let's use our calculator. Okay, and again, I'll impress upon you the importance of parentheses. So parenthesis, we're making sure that we're in the complex mode. 1 minus 3, and we'll use the letter I because our calculator has I for a complex number. Subtract. Again, use parentheses, 1 plus 3, I, and enter. And I got negative 6i, which means negative 6j in the technical world. and I got the same answer here and here. So there you have it. Adding and subtracting complex numbers graphically and checking them with a calculator. Remember the key points. We have a real axis and an imaginary axis. Okay, that's important to note. And then we can do this graphically using our parallelogram method.